We proceed with our next speaker. Our next speaker will be Oresztesz, and I will ask to join him in our virtual studio. Oresztesz, hi, how are you?
Hello everyone. I'm fine, thanks.
Cool. Also, let's join to us the moderator of this talk, Roman. He also in the waiting room. Roman, hi.
Hello.
Yeah, now we can see and hear you. Okay, so just like a few minutes left till we start the talk itself. Before that, Oresztesz, could you tell us in a few words what your talk would be about?
Yes, so my presentation will be a little bit about software design and partially about test-driven development. So we are going to go through a real problem and make a solution using TDD. So writing tests first.
Okay, great. That sounds great, and I think it should be very, very, very useful, like as all the talks we have here on the conference. Roman, I have a question to you. How often do you use TDD practice in your real work?
Generally, I never use TDD practice in my work.
Do you know what it is?
Yes, I know what it is, and I know benefits and what can we do with it, and what is not good with TDD, in which case it's not applicable. But all my previous project was without TDD, and it's not possible to include TDD in these projects.
Well, yeah, that does make sense. So, guys, who listen to us, so we have YouTube chat, and shortly in this YouTube chat, and in our main Telegram chat, it already appears the link to special Telegram chat for questions to Oresztesz. So please join this Telegram chat and just write anywhere there or in YouTube if you use TDD. Just write pluses somewhere, so we would know how many people are listening to us carefully and how many of you use TDD. Or write minus, for example, if you don't. Oresztesz, we have a comment in chat that speaker with cutest room background detected.
Sorry, can you repeat it again?
Yes, we have a comment.
Oh, the
in
cutest
chat
room.
That's
the
background. You have
background.
the cutest room for all the conference.
Thanks.
Okay then. So I think, so my question about TDD, so we have some pluses, we have some minuses, we have some big minus in the chat. So somebody, some more pluses. So somebody used TDD, somebody not. So yeah, I really hope that this talk would be useful for you, because he would be real test case. By the way, I know that in your talk you would use the system to score scores in bowling, right?
Yeah, that's right.
Okay, guys. So do you know how scores in bowling are scored? Just type say pluses in the chat. Do you know all the corner cases and stuff with that? So yeah, we have some delay between translation and the chat, so probably it would be with some delay, guys will say something. So anyway, I think that this will be useful for you. I just want to remind you that we have in description all the links about what's going on here. We have special event Fight Club, which is going through all the conference, so come and join, and you will be able to win the IntelliJ IDEA license for 1 year. Also, in the end of the conference, we'll have after party where you would be able also to participate in fun activities and win 1 year license for IntelliJ. That's it what I wanted to share. Now let's start the talk. Oresztesz, good luck.
Thank you. Okay, so again, hello everybody. Today we are going to hold a practical TDD session that's entitled as Protect Your Invariants. My name is, again, Oresztesz Margaritisz, and I work here at EPAM as a Chief Software Engineer currently. So, yeah, as it was heard, we are going to implement a bowling game, or a score evaluation for a bowling game, But before do that, maybe it's good to revise the basic rules of TDD. I won't go into details, just give you a short summary of what are these rules and what do they mean in brief. Okay, so there are different phases in test-driven development. There are actually 3 phases for different kind of activities. There is this called red phase, when you actually just implement one additional test case that needs to fail. That basically can be seen as the next specification of the next feature that you are targeting. All right, then comes the green phase. And in the green phase, you actually just make enough code to make the previous test that failed to pass. That ensures that you don't stuck into just coding and implementing features after features before having another test introduced. And then we have this kind of refactor phase. And in the refactor phase, we're just trying to make things still working the same way, but with a better design. So if you think about these phases, you can say that each phase concentrates on different activities during development. So the red phase usually is focusing on just the specification, green phase focusing on implementation, the refactor phase is focusing on design. All right, so let's talk about the bowling game itself. And let's talk about the terms of this specific domain that's related with the scoring of the bowling game, because without you knowing the rules, it would be hard to understand the code itself. Okay, so it's necessary that we go through the basic meanings and rules of the game itself. All right, so what you can see on the screen is just a small part of the score sheet that's used during bowling. It's enough for me to actually show you the different kind of terms. We will go through the score sheet from the beginning to the end by applying also the examples later. All right, now we're just focusing on the terms themselves. There is one specific term called pins, and basically pins means these kind of things in the bowling um, game that you are trying to hit down with your ball. All right, whenever you hit down an amount of pins with your ball, you have to write down the amount of pins hit down here in your score sheet. All right. There is another special term called frame. Here you can see a frame. This is another frame. And actually, the bowling game itself consists 10 frames, and the floor will be reset on every frame. So after hitting down a specific amount of pins, you will start over from 10 pins, and then you need to hit down those 10 pins again. So here in the beginning, probably you know that these pins will be just set up in the floor with something like that, and the sum of the pins that you have here is just 10. All right, then you just hit down a specific amount from these pins for the first try of the first frame. Then after that, you have another chance to hit down the rest of the pins. And then the floor is reset by the machine after you proceed for the next frame. All right. Spare is a specific kind of situation when you are able to hit down all the 10 pins within 2 tries. So it's noted in the game itself by this specific kind of half full box you can see here. This means that I was able to hit down all the 10 pins for this within these 2 attempts. So that also means that the sum of the pins that I've hit down for the specific frame is 10. So even if it's not written down, you can see that or say that I just hit down here or hit here 5 pins, because 5 plus 5 is 10. And here I've hit down 4 pins because 6 plus 4 is also 10. And there's other kind of specific term, which is called strike. You can see it here. This means that I, again, was able to hit down all the pins, but now I made it for within the first attempt. So I was able to hit down everything with just one try. That means that the hidden score here is 10 actually, and it's noted in the score sheet by using this full box. Okay, so now this is how the whole score sheet looks like. You can see that 10 frames here, so we have 10 frames. That's the scope of the whole game. All right, now we just go through the score sheet itself, just zoom it in and talk about the score evaluation one by one. All right, let me just change the color because I think it will be more visible. So for the first attempt, I just hit down 1 pin here. For the second attempt, I hit 4 here. So the current score for me is 5. Then I just proceed with the next frame. So here comes the next frame. And I hit down on 4 plus 5, that's plus 9. That gives me the final score of 14. Now, this is a spare. I know this because of this specific notation that you can see here. Even though it's hidden, the score here is 4. And I get, whenever I have a spare, I get additional bonuses. The additional bonus for spare is the score of the next attempt. So if I hit down 5 pins here, I get an additional plus 5 bonus here. So here the additional score is 10 plus the bonus, which is 5. 10 plus 5, which is 15. That gives me the score of 29. And then we saw that we had here 29. Then I have, again, a spare. So the hidden score is here 5. Here I have a strike. So again, this is a special case. Here the hidden score that is not seen in this sheet is 10. So here the additional bonus is 10 plus 10, that's 20. That's why I have the score of 49. All right. For the strike, I also get some additional bonuses. But for strike, the number of the bonuses that I get for the specific round is the value of the next two rows. So not just the next row, but the next 2 rows. So even though I hit down no pins in the first try, I still have the bonus of +1. That's why I have the score of +11. That's why I get the score of 60 here. All right, here I just have +1. We go again forward. Here the score was 61. Okay, here I have again a spare. So again, some of the pins hit down is 10 again. The additional score that I get as a bonus is 6. That's why I get +16. Oh, sorry, not 14, 16. Yeah. Here again, I have a 4. I hit a strike, so that means that here I have a 10, even though it's not noted. So here the additional number of bonuses is 10 plus the value of next row, which is fortunately again 10. That's why I have 20 here. That's why I have 97 as the score. Here I have a strike and the 10th frame. Note that the 10th frame is it's a bit different than the others. Okay, but here the notation is the same. So I had a spare here, meaning that I have the score of 8. So when I have a strike, the number of the bonuses is the number hit down by the next 2 rows. So again, it's 2 plus 8, that's +10. I have +10 here because of this number, that gives me again +20. Now, in the 10th frame, actually I have 3 tries, not just 2. And the rule is the following. If I hit down, let's say, 2 rows or 2 pins in the first attempt, then 2 pins again, this means the game's over. All right, so I just have the score of 4. If I hit down 2 pins at the first attempt, then I get a spare. So that means that I have 8 for the next attempt. Like here, I get the chance to roll another round. So I get the, like in this case, I just hit down 6 pins. So here for the 10th frame, the sum of the points I get is the total number of the pins hit down in this frame. So that means that this is +16 for me. All right, and the maximum amount that you can hit down is that you hit down a strike, right? Maybe the notation is not correct that I'm doing, but imagine that you hit down a strike, that means 10 for you. Then you hit down again 10 for the next attempt. And in this case, if you hit down a strike, even though you haven't hit down all the pins here, now you have the chance to have another try. Okay, so 10 plus 10 plus 10 is also a valid number here. 10 plus, I don't know, 3 plus 3 is another kind of valid number here. So if you have a strike, then you have additional 2 attempts to go. Right? Now let's talk about the representation of how the whole score sheet can be presented. Let's do a little bit of design ahead before we jump into coding. All right. So one of the obvious solutions would be to try to map one by one each of these small boxes into an array. But that would mean, as you can see here, that I will have some holes here. I can use something like a special number like -1 to identify these holes, or some other number. But somehow these have to be distinguished from the others. All right. Another option would be to don't just punch in holes into this array, use the whole array, but make the length of the array various. So what could happen is that the end of the array is not getting used, but still I have to understand, and in this case, how the mapping changed. So here I had the 10, so I can write this number here, like here. If I have an array that's shorter, then okay, I will have here a 10, but I should know then that this index is skipped. This means that here, in the previous example, the mapping will be 1 to 1. So here I will write the 0 in this index. But in this case, this has to go up to the next index. Then somehow note that, okay, this was a strike. So the next attempt is not stored. Instead of that, I just jump into another frame and have the first value noted here. All right. So this might work, at least for some level, unless we want to also capture the invariants that we have in our little domain. All right, so let's talk about what are these invariants now for a very brief moment. First of all, I only have 10 pins that I can hit down. So I cannot write something like 11 here. That's not a valid value. All right, or some different numbers. Every number here is less than 10. It's still followable in the array representation at some level. The 10th frame is somewhat special. I either have 2 or 3 rows to go, depending on the result of the first row or the sum of the first 2 rows, and so on. And one that's very special kind of a requirement for just frames is that the sum of rows is always 10. So even though I have like 1 here, I cannot have the score of 10 in the next index. So if I want to keep this invariant in the array, I somehow have to figure out at which index I am whenever I hit a strike or not. And depending on the representation that I chose, I will have to play around with the indexes and apply these rules accordingly, which might make our code less readable. And yeah, what's also important, it's a bit hard to see here in the index representation or the array representation, is that I have 10 frames. So if I just go ahead and store values in the array, I won't store this kind of specific invariance that, right, I have 10 frames and I won't represent this so obviously in my implementation itself. All right, one of the other good questions is that where should I enforce these invariants? All right, if you think about something like the model view controller, or if you think about different layers of your application, like a domain layer, an application layer, and the UI layer, you might think that, all right, obviously I don't want to put every kind of invariant enforcement into the UI or the user interface, because anyway, I have to do another round of validation later on. It might be obvious that this should come close to the entry point of the application. So when later on I make this call here, then I know that I just have to deal with valid numbers. But this would mean that, okay, if I put the invariants or the enforcing these rules as some kind of validation into the boundary of the application, that I will have some kind of dependencies, either directly from my model to the framework or the code that's in the controller. Or if I try to inverse the dependency, then indirectly I will have an interface and an implementation. But anyway, this means more dependencies between different layers. So what I would suggest to do is just encapsulate everything at once in the domain itself. Okay, so let's try to do a little bit of modeling in terms of classes. I should aim to have a game class which consists 10 frames, then some kind of special frame which is called the 10th frame, and the rest of them will be subclassed and named as intermediate frames. All right. You can see from these mappings of the invariants is that 10 pins has to be enforced by the intermediate frame, and also about the 10th frame. So also an arrow will go here, and the enforcing of the special rule of 2 or 3 rows we just left for the 10th frame, and the enforcing of the sum of rows then has to be dealt with the intermediate and 10th frame. And by nature, by using this kind of composition and by having this fixed amount of frames or fixed amount of associations here, I just enforce that I have 10 frames here in the game itself. All right. So what's strange is that what you can see on the diagram immediately is that only one invariant is pointing to the game class. Or so if I would want to do everything inside one class and don't have this kind of composition, then it would be harder to implement and to manage all these rules at once, because it might overcomplicate the implementation. All right, so now let's jump to the coding and start talking about how or about what should happen really at class level. All right, so first I would like to talk about this kind of simple implementation that you might start with if you are using arrays. So I just started with a game class and haven't planned to use any other kind of class hierarchy or decompose my problem into smaller classes. And I started with just a primitive array of rows, and the score should be just then the sum of these values stored here. Now immediately, what you will see on the screen is that I talk, so in the code itself, I don't talk about the frames. So it's not shown anywhere in the code. So also here there is a number which might be hard to interpret if you are not familiar with the nature of bowling game. It's true that you could easily just jump off to the internet and search for the rules, but if you, let's say, if this is a financial application, it might not be so easy. So there is a hidden term or concept here that's not seen, which is called frame actually. So if I jump to the test now, let's see how I'm able to get away with this implementation. All right. So just to save some time, I have prepared the tests ahead, but I will do the implementation from this state. So here you can see the game class. I will try to roll without hitting down any pins, and the score should be then 0. Obviously, this array representation is enough to make this test pass. I have another one, which now just tries to hit down one pin. Score should be 1. This one is going to pass again. Then I will try to do an implementation with a full game. So I have 20 tries to go, 20 attempts to go. I will try to hit down one pin in every case. The sum of the score should be, or the sum of these scores in each frame should be 20 in this case. All right. This is also quite okay. Now, after having this kind of very simple implementation, then I might want to explore what should happen, or I want to specify what should happen if I have something that's an illegal move. So let's hit down 7 pins in the first attempt in the first frame, but still in the first frame again I have this score of 7. It should be invalid. So if you again go back to the score sheet, try to visualize how this looks like. This would mean that in the box itself, I have a 7 and another 7. This is not valid because the sum of these rows here is 14. Okay, and here's the situation where the problem comes. So when I want to really represent this in the game itself, might be troubling because I don't really know where I am. I need to treat this kind of indexing a bit special way. So that was the point when actually I decided that okay, maybe I need to compose my problem into certain sub-problems. So instead of talking about this solution, I should really talk about what should happen in a frame itself, the simplest way I'm able to. So now let's jump to another test, which will just talk about the intermediate frame. So if you remember the class diagram here, this is the intermediate frame we are at, and this is what we are going to specify and implement. All right, so the first specification will say the following. So if I just roll the 3, and 7, then I should get back 3 as the first row and 7 as the second row. So I'd also try to be more specific here, make these kind of concepts more explicit in my code. So I explicitly say here that I have 2 rows in this frame. First row and second row don't need to do any indexing. And this is similar to this kind of small boxes here. So this is what's going to represent this concept in my code. First, I make the test fail because we are doing TDD. All right, then go ahead here to the intermediate frame. Again, I just did some work ahead and made this class hierarchy with some helper methods. I should say that if tries equals first try, I will go ahead and set first row. Constant here, first try 0, tries is 0 as initial value. All right. Let's see if the test we are going to pass. I'm going to pass because I have a next try to go. So else I just set the second row and increase the value. It's enough for me to pass the first test. So we just go ahead again and make some additional features by specifying more features. So here comes the first invariant. So I immediately try to do more to verify my design. So if I try to do more tries than 2, I should get an exception here. All right. And I will try to implement this one. I have a helper method that I will talk about after the implementation. So if the tries is less than the maximum tries, which is just simply 2, I guess, I will throw an exception. All right, that made my test pass. So this actually this helper method again, just helping me to write less, just comparing two numbers that I'm giving here. All right, so I just compare the tries to the maximum, then throw a predefined exception here. So we can go back to the test, continue with the next specification. It says that, okay, if I just roll 10 pins, then the score should be 10, even without talking about anything about bonuses. This is the first time when I need to implement the score. I will just go ahead and give back the sum of the first and the second row. Go ahead with the implementation. All right. Now, here comes the same test case that actually failed, if you remember here in the gain test. So again, I'm trying to put more pressure on the design and figure out whenever this is easier to implement, if I choose another kind of approach or not. So that's why this is what I'm going to do next. Note that again, I have 7 pins and 7 pins, but the sum of pins should be not more than 10 within a frame. So this is what we are going to specify. So verify number of pins is less than maximum. Here I write pins. This won't be enough, actually. I will talk about the helper method first. So here I don't need 2 arguments because the total number of pins is always 10. It's a fixed number. So here I explicitly have something in the code saying that, at least. If the parameter compared to that is bigger, of course, then I will throw an exception. Let's see if this making the test pass. I hope not. No, it won't. Yeah, because here the sum of the first and the second row is more than 10. So what I will do here, just I will add the first row's value to the pins that I'm trying to store here. And if it's larger, then I will throw an exception. Larger than expected, then goes the exception. All right, now comes the implementation of the first rule that actually tries to deal with a spare. So for this, I include a new method called setNext. I just have another intermediate frame. It's going to be the next frame. Here I have a spare. So what this will mean, if I try to visualize that, is that I had a score of 3 here, 3, then a 7. All right. This is not noted usually, so you have this triangle. All right. And then the next score that I store here is 2. So that means that these frames' total score should be 12. 10 plus 2. That's what I will write here. I don't try to calculate yet the score of this frame. So note that the score method is just focusing on the frames itself. I'm just calling it on the frame. All right. Now, implementing this one, we'll need a better implementation of the score method. So let's store frame score here. A minute. If this is a spare, again, another helper method, then I will return frame score plus next get first row. Okay, I just jumped ahead for a minute because it's not yet existing. So you can see here that the setNext is not implemented. So I will just implement here the next placeholder for the next frame, and then get the first row if this is a spare. Now let's see if this works. Okay. No, because I made a mistake here somewhere. By default, I return the frame score. Let's see if this works. Yeah, it works, but I have regression, unfortunately, because I have an unpointer exception. So I need another method. I don't have this next specified yet for any reason. I will just return the frame score. Return. Next is not known. That makes my next test case to pass. Now let's go and proceed with the next one, which is going to deal with strikes. Again, I just rolled a 10 here for the first frame. If I try to roll anything else, note that I'm going to get that exception that I implemented previously. So that's why I don't need to deal with this case anymore. So I get this nice illegal row exception. So all I can do is just store some additional values in the next frame. And I just get back not the value that expected. The sum of these should be 17 instead of 12. So let's talk about this helper method first. Note that, again, it's quite obvious, so that's why it's I just spared the time of implementing these and just went ahead and specified these ones in the base class. So I get to spare you the first and the second row. Sum of the first and second row is 10. I can also say that it should be the total number of pins instead of using this magic number. Here also the same for strike. So if I have a strike, I should return same score plus next, at first row plus next, at second row, and else. If this is, I can do it even like that if you want to, but first let's see if the test is going to pass. It's passing. Let's see if we have any regression here by running all the tests. No, we don't have regression, so I can do it like that even. There are many kind of flavors for implementing this method. You might not want to have multiple returns. Also, if you want to, this is the phase when you can make the refactoring and work on just the method itself after knowing that everything's working. All right. But now, for now, let's jump to the next method and let's start our next test case, because I was curious what happens if I roll a strike. I have the next frame, but no score there. So I just wanted to make sure that everything is working still, nothing is broken. This is true. And without going to the next test, now we will jump into doing some work on the 10th frame itself. So again, going back here, 10th frame is this kind of special frame where I have 3 attempts. Also here in the class hierarchy, this was the 10th frame. So that's what we are going to implement next. Again, what should happen if the same things actually is seen here. So what should happen if I have 2 tries? Okay, if I run the test, it should fail, because in the 10th frame, I should not have anything prepared. Now, what I could just do to make this pass is just copy over the 10th frame, the same implementation, and see if it works. Okay, just moving intermediate frame close. I needed these ones, I guess. I hope so. The maximum tries is here. Okay, will it make it pass? Yeah. So what I will do, instead of thinking about the proper solution or whenever this is the valid solution, I just first specify the next requirement. I just made it pass. I want to make more tests before jumping into the next defactor phase. What should happen if I have 3 trials? Even though there are cases when I can have 3 tries in a 10th frame, if I have not had any strike or spark, it should not be allowed. So there should be again some similar kind of invariant that's going to protect my frame from storing this value here. So let's go back to the frame and let's say that verify number of tries is less than maximum. I have here the tries and I have here maximum tries. Same again as before. Okay, it's very close to the intermediate frame. But what should happen if I have a spare? So note that I had a spare here, right? Again, some small amount of drawing, so you can imagine that. I have now 3 brackets here. All right, I have a 3. Then I have a spare, which means that I have this triangle. And I should be allowed to, again, have the score here of 2, because I have an extra round to go. then I receive an exception if I try it again. All right, let's see if it fails. Yeah, it does. And I get the exception. The problem is that this should be various, so I'm just going to get maximum price. I'm just going to replace that with the method. Wait a second, all right. Which is going to be, if this is a spare for a strike, it should return maximum tries plus 1 because I get another attempt, or maximum tries, right? Let's see what happens. So am I able to just implement this correctly? Yeah. I know I jumped ahead with this one. So let's see if the next test case, which is testing the strike, is also going to pass. It should. So if I'm confident, I don't have to follow the rules so strictly in TDD. So if I'm confident with the next step, it's okay to jump a little bit ahead or go slower whenever you think you are uncertain and need some more control. Okay, this is the first test case when I have the score implementation. All right, the 10th frame, this should be at first row, at second row. As the first guess, why not? Same as in the intermediate frame. Work there, should work here. All right. Again, another invariant. So if I roll 9, and I roll 2 here, this should not be allowed. This should be the verify number of pins is less than maximum. Let's try the same here. Get first row plus pins. Same as in the intermediate frame. Adding the exception signature. Okay, I get regression again. And the reason for that is that if I have a strike, then this is not true. So this should be replaced with something else. So I'm just going to extract this as a method, is third row allowed. So if the third row allowed is the same here, going to be used here. So if the third row is allowed, then this rule is not going to be valid, only when third row is not allowed. Because if I try to do it like that, then I won't be able to have the maximum number of score of 30 in the 10th frame. All right. Okay, let's try to improve the spare implementation. I have three rows to go. Score should be the sum of these 3 rows here. It's not exactly the number that I would expect. So get first row plus get second row. And this is the point when I figured out, okay, I just forgot to make this a bit smarter. I need also a second try here. Is 1. Then else need to store the value of the third row. Oops, not local variable, but the field should be capturing the third row and just should have add the third row to this sum of these scores. And this is going to pass as well. Okay, so it's true that I have 3 attempts in the 10th frame, but not 4, of course. So I need to test this case as well whenever it gives me a no more rolls exception. That's true. So I can continue. Right. If I have a strike, then I'm allowed to roll at least once the next time, and I should get back the score here. Okay, so imagine that I'm again then extending this test with the additional attempt. So here again, the amount of score that I expect would be 13. But if I have a strike, then I have 2 tries to go, not just 1. Okay. Now, in any time when I have more than 10 pins, I should get back an illegal roll exception, because that's also an invariant that I somehow missed, because this should be checked also here, that the number of pins is less than 10, even when I have the third roll allowed. So I should not allow more than 10 pins, either in the second or the third try with 10th frame. That's not a valid move. Yeah. 3 strikes is the maximum amount of score. So I should get back a 30 here at the maximum number of the score for the 10th frame. All right, so I think we made a quite good progress. So why not we go back to the game class and try to change the implementation using what we've done so far. So I will have a frame array of frames, which will include 10 frames. So this immediately tells in my code that a game consists 10 frames, explicitly saying that, okay, this is what's in my domain, or this is how I represent the game. All right, so what we have to do, only thing that we have to do is make the constructor appropriately and construct the game class or the game instance appropriately. And after that, we have to just delegate the role method to the frame itself. So first frame will be an intermediate frame. What I'm going to do is that for each number here, I want to add a new frame for a specific index. I need to do that. It needs to be a frame that, because I need to also call the set next on each previous frame. I have to use a set next here. Previous index. Left is that I should have an add frame with the index of 9, but this will be a 10th frame this time. Role will change. We just delegate this call to the current frame. I just sum the score of each frame that I included. And let's see how this is able to capture these requirements that I previously implemented. The first one's working okay. That might give us some hope. Second one is, again, working all right. Third one, when I try to play a full game, of course, will fail. I have a no more else exception very early in the game itself. And this is because I forgot to actually increment this index here. How should I do that? So probably I need something like frames turn. If I don't have any rows, I should increase the increment the turns, number of turns, or the turn index. This needs to be implemented. So let's go back to the intermediate frame test. Let's try to do that. By default, it should be false. I have to implement no more rows also in the intermediate and the 10th frame. I can just return true. Might be okay. Without strike or spare, if I roll once, no more rows should be false. If I roll the second time, it should be true. I should do here something. What did I use here? Tries. Okay. Not here. Here, tries equals maximum tries. Let's try that one. Yeah. Okay. This is going to pass now. With a spare, same thing, but with a strike, that's going to be quite different. I should have no more rows for the second after the second attempt. Yeah. So here, we strike or I just depleted the number of tries. Okay, now let's jump to the 10th frame. Again, we use the same trick, so I will just go back to the 10th frame or the intermediate frame. If I can find that, yeah. Try to copy over the no more rows. Return that as a value and see how far I can go with that. So 10th frame test with the first attempt, it should be false. That's going to pass. Second attempt should be false again. And I don't have any strike or spare, then I have no more rows. Now with the spare, actually, you can see that I have more tries to go here. So let's try to implement this in a smart way. If I use the get maximum tries method, because in theory, this should be not a fixed value. I just reuse the same method that I already implemented. This is going to pass. It's going to pass as well. It's testing the same for strike. So for strike, I also have 3 attempts, and after that, I don't have any more rows to go. If I go back to the test, I use this method itself. Now I go back again to the game test. See if I'm able now to proceed with the test with the game. In theory, because game is just delegating everything to the frames, it should not do anything more complicated than that. So you can see here also that even though it's throwing the same exception, it's not enforcing that with any rule. That's the responsibility of the frame. Fortunately, that's going to pass as well. Now, what's happening if I have a spare? I had a spare here. See, so the score here is 10. And I have a score of 8. Now, the total number that I get, the score is 23. It's going to work because frames are working properly. Now, let's test with all strikes. Be tricky, so again, I have to go back to drawing. I made a mistake actually, because here I have first frame, second frame, and third frame. I have a strike here, and a strike here. Now the score for the first frame itself should be 30, because I have 10 plus next row, which is 10, plus next row, which is 10. So this is 30. The next one, because I don't finish the game here, I don't know the additional values, but again, this should be 10 plus anything that comes next. So instead of, so this is 20 then, and this is 10 for now. Instead of jumping to just the next frame and reaching out to just the next frame to understand this value and this value, I have to jump one frame ahead in case when it's a strike to understand the number here. So even though this might be 0 because that's a default value. This should not be used. And that's quite a mistake that I made, unfortunately, when writing the score, which needs to be fixed now. I will try to do it without additional tests, just because I feel confident enough. So instead of going for the next get first roll, get second roll, I should go here for a special method, get second roll for bonus. Might not be nice or might not be the best naming, but for now, let's see how it works. Get second roll for bonus should return, if I'm a strike, should return next first roll. So this is the advancing with one additional frame, else get second roll. All right. Oh, forgot the returns. Sorry for that. Going to make our the game test pass. Now we are going to test with a perfect game. I have 12 attempts here, 10 plus the 2 additional rolls at the 10th frame, and 300 should be the value for the perfect game, or the sum of the score. Yeah, there is an unsupported operation exception here, just because the 10th frame is not implementing this method, so I'm just going to use the get second row in this case explicitly, because that should always exist. Now, as the final example, I try to make it real, include this example here with the scores that you can see here. That's why the final number of the final score should be 133, which you can see here at the end. So let's see if it works. The implementation is finished, so a test should pass. Sorry, this was debug mode, so I just run again all tests. Yeah, so actually this finishes up or TDD exercise. This is the time when usually just revisit the solution, make some additional refactoring if that's necessary. So note that, for instance, here in the 10th frame and in the intermediate frame, we might have some duplicates that could be extracted or moved up even further. In the intermediate frame, we have this null check, and we have to think about that whenever it's worth replacing it with, let's say, a default object, if that's okay, or just experiment with the design a little bit and improve it any further. But for now, I think we will finish up this exercise. So thank you very much for listening to this presentation. As the summary or the conclusion, I want to say that very often for me, TDD definitely helps. So I noticed that it's making my design better, just simply because it is making my code testable. All right, and I felt that I can make this kind of design decisions in their own phase instead of just jumping off into each of these parts or phases of coding that I was talking about in the beginning of the talk. And often what I use to just self-check the implementation itself is just include this kind of invariants right into the domain. So whenever there is some inconsistency, immediately after that, I just highlight this with an exception or with a similar behavior, so I know that there was some mistake made previously. All right, so that was all for me. And again, thanks for listening. You will have these links here on the right side after receiving these slides. Feel free to reach out to me either by writing me a message. If you have any further questions, or I encourage you to also look at my GitHub account. I have also this code base with the examples and with the slides in GitHub as well. So just want to say again, thanks. You will see additional links at the last slide that's actually showing these parts in the GitHub repo, and there will be also a coding story available where I have a quite different approach, but you can follow it step by step. Again, revisit the steps, make it by yourself, and see if you have reached the same solution as me or some different solutions.
Okay. Thanks a lot. Thanks a lot for this great presentation. I really hope it was useful, guys. Please type pluses in the chat if it was. So we don't have a lot of questions at the moment. I hope they will be a bit later. Oh, everything is pretty clear. And like now everyone is fans of TDD approach. So you convince everyone. So nobody want to claim about that. I have a question to you from my side. So how often do you really use TDD approach in your career?
Currently, because usually I'm not writing production-ready code, I'm not using it. Previously, I was using it. I don't want to lie to you, but for around 6 to 8 years, after a very early phase of my career, when actually I bought this book, which is I think called TDD by example. So it's quite a short book. It's quite practical. It has many code examples, and I just started using it. And I think you don't have to have the whole team agree that we are doing TDD or something like that. Nobody cares if you are writing your tests first and your implementation next. It's not affecting the overall teamwork or something, because they will just receive, the pull requests and see the end result, but they don't see the coding itself when it's done. So yeah, I'm using it for quite a while.
Okay, and I have second question.
Okay.
How often do you play bowling?
I played it quite long ago because of course the restrictions, you cannot go anywhere right now. But previously I played it in a few times with my family. I had no idea how the scoring is done because it was done by the machine, and we were not even have the opportunity to figure out what we are doing. We were just enjoying the game, so that's quite automated right now, I think.
Okay, cool. So I see we have a question. So Roma, I
Okay.
pass the voice to you.
Yeah, we have a question in the chat. Do you start with AC tests and going deeper and deeper, or is it focus on the domain layer first?
That depends really on the context, on the application. So it's hard to say which approach is the best. Usually when you have a project which is built up by test first approach or by covered, which we test with a high coverage, it's easier to start from the domain if requirements are clear. Very often you have to use this kind of outside to inside technique when you need to write one failing acceptance test which remains failed for a longer time. Then you can go deeper and figure out the internals. So yeah, so not every time I start with TDD. Sometimes it's better to just jump off with experimenting. But also you can use something that's called learning test just to figure out how something is working. For instance, recently I started learning Webflux and how this kind of reactive libraries are working with TDD. So I started writing tests which are self-verifying, and then it was easier to write the test for the real application later on. I hope I answered your question.
Yeah, I have a question too. Maybe you provided some suggestion. If I start to write TDD tests on the project, how many functionality I can cover by TDD test before I start writing the functionality itself?
You need to focus only one thing at once, all right? Because otherwise, you will just stick in that specific phase for a very long time. So if we go back to the phases, And what I can say is that you should not spend too much time on each phase. Ideally, each phase should be not much than just a few minutes until you figure out your next step. Okay, so I think one test should just focus on one feature or some small addition, then implementation also, just to make it pass. And then on refactoring, you can just make a smaller or larger refactoring depending on the situation that you are in.
Okay, thank you. And
Okay. Yeah, seems we
yeah,
don't have any more questions here. And now the Zoom discussion room is starting. So we already have a link in our YouTube chat. I see it. And we have a link in our chat in Telegram. So guys, first of all, Oresztesz, thank you very much for your talk. It was awesome. And thank you very much for participating in Java Day.
Thanks for listening.
Roman, yeah, and Roman, thank you very much for moderation. Thank you, guys.